Hi everyone. Today we're going to be demonstrating how the FLS 110, the world's smallest flow sensor, can be used to measure the airflow through this household air purifier. Now, for those of you who aren't familiar with the FLS 110, I have here a pretty tiny PCB, and if you can see there, that black component on the PCB, that is the FLS 110. It's 3.5 millimeters by 3.5 millimeters. It's really tiny. And we're going to be taking this sensor on this PCB and installing it into this air purifier so that we can accurately measure the mass flow moving through the air purifier. Now, to do that, we're going to need a flow fixture, and normally the flow fixture would be designed in and would be part of the product, but because this is a retrofit today, I've designed this simple 3D printed flow fixture to get us started. And here is the FLS 110 on its little PCB installed in the flow fixture. And this flow fixture generates a pressure drop which the FLS 110 is able to measure. Now we need to install this fixture into the air purifier, and then we'll be able to measure very accurately the mass flow going through the purifier. To do that, I'm just going to take the top off the air purifier here. Now this is typically done to change the filter, and instead I'm just going to install the fixture there, like so. Carefully route the flex cable out of the way, and then we'll just simply reinstall the top of the air purifier like so. And that's all there is to it. When the FLS 110 is designed into a product, it will communicate with other microcontrollers in the system over I2C to do functions such as maintain a target flow rate or monitor changes in flow. In this case, we don't have other microcontrollers in the system that we can access because this is a retrofit. So we've got this USB adapter, which simply takes the I2C input from the FLS 110 and converts it to serial USB, which I'm going to plug into this laptop that I've got here, and then we can look at the data from the FLS 110 as we run the air purifier. So here we have the FLS 110 connected to the evaluation kit software and the air purifier switched on. And I'm going to occlude a bit of the air purifier's intake with this piece of paper. And you can see that we get a 3 or 4% drop in flow, which is very easily visible on the output from the FLS 110. Now, the aim of measuring flow like this with the FLS 110 could be to determine the status of a filter. So as your filter clogs in the air purifier, you'll see the flow rate drop over time at the same power setting, and you can inform the user when the filter is clogged enough that they should replace it with a new one. Another interesting use for the FLS 110 in air purification is to flow compensate various gas sensors, particularly particulate monitors. These laser particulate monitors are very sensitive to flow rate in their calculation of particle density. And if you can accurately compensate that measurement for flow rate, you can get a much more accurate determination of the air quality in your room and know whether the air purifier should be working harder or whether you can turn it down to produce less noise and still achieve the right air quality for the occupants of the room.